to it. I work in the, thank you. I work in the platform security and compliance. We do a lot of work in graph databases, and we started hosting these graph database user groups as an outreach program to learn from other people and have other people learn from us. We are going to get started here in a few minutes. Jason and Daniel from Neo4j are going to be here. They're going to kind of kick us off. Logistically, I've said it once, I'll say it again. The bathrooms are right outside the doors here. You can see the signs on the wall. If you go past the bathrooms a little bit, there's an alcove in there. You can get waters. There's waters and drinks here as well, but there's other things, vending machines, whatnot. Anybody have any questions? We're probably like 5 more minutes before we get started. Any questions? Anybody got a joke? Just kidding. Just kidding. All right, so give us 5 minutes and we'll get started. We'll introduce some of our esteemed guests that are on Zoom, Barbara and David being one of them. And then I think I saw Al Liu on there too, and he's an esteemed guest of mine. So thanks, Al, for showing up.
Hi, Chad.
All right, so give us 5 more minutes and then Daniel will kick us off.
So,
Thank you, sir. So as I said before, my name is Chad Close. I work here at Intuit, and this is Daniel Kang. This is my partner in crime in setting these things up, along with Jason Koo. They're from Neo4j. I'm from Intuit. We have a partnership here with the graph database user group. Daniel, do you want to kick us off? And I think we wanted to introduce Barbara and David possibly, and we're going to limit the introductions to just a few.
yeah, absolutely. We'll keep this pretty short and sweet. Appreciate everybody making the time to come out here. Please enjoy yourself to all the food and drinks that you can get to. I think, obviously AI, LLM, big hot topic right now, and we'd love to kind of demonstrate how it's being applied in the tech world right now, as well as potentially also alongside what graph database technology has to bring. With that being said, I wanted to introduce you over to Barbara. Barbara, I believe you should not be muted, and the floor will be yours.
Yes, hello everyone. Well, I'm organizer of the San Diego ChatGTP AI for Good Meetup. And David Gunning, who you can see in the picture there, actually spoke at our last meetup. And, when I saw how big LLMs were coming and having worked with Dave for decades and knowing the importance of AI for good, etc., I felt compelled to start it. So I was recruited. I started my doctorate in South Africa in AI back in the day, built trading systems on Wall Street, and ended up working at DARPA for Dave on programs, in question answering, like high performance knowledge bases, and ultimately PAL, Siri, which he can tell you a little bit about. And he moved on, and his best program he was known for, I think, was XAI, the Explainable Artificial Intelligence Program. But maybe that's a good time for you to introduce yourself, Dave.
Just hello, everybody. Any of you who were at the last talk know my whole background. I've worked in AI for a long time, especially at DARPA and a few other places. So it's interesting to get to check in with this meetup. Interested in hearing some of today's topics about graph databases and large language models. Next.
Oh, thank you. Okay. All right. So we're going to jump into our first presentation of the night. Thomas will be showing off Pydoxtools. Yeah, why don't I hand it off to you? Okay.
All right. Welcome. I'm Thomas. I work with graphs and AI since quite a while. And I've been working on this framework for quite a while now, called Pydoxtools, and I think it's quite useful for graph purposes, everything graph. And yeah, that's why I'm here. I want to present it a little bit. It's an open source tool, and I hope that it might be of use for some people. Yeah, but in order to get that across, I need to present it. So that's why I'm here. So my personal motivation why I did this. So I am an engineer, and I used to be in research with a lot of design automation tasks, and for that, already quite a while ago, you need very high quality data, and that's just not available. And you also only needed one. So usually the data that you find that is high quality is for tasks that you do very often. But in engineering, if you build a project once and you do the research once, then nobody will pay for getting the data. So making that data available. So that's why this tool basically was created to get that data. And so just to show some use cases where this was used, for example, there's a little satellite project, which is my old colleagues in the lower right. This is an actual picture on the space station. So we use this to create modular space systems, basically, and for the engineering tasks that are in there, and to research components and this kind of stuff. And another use case that's very similar. So all the pictures that you can see on the right is when you Google for systems design, and you want to build systems buses. And being in a graph meetup right now, you can already see the connection here now. Those are mostly graphs. So, I mean, they're all system bus diagrams, but every single system bus is also a graph. And so the need for something that works with graphs kind of naturally arises in this area. If you want to, so our motivation is design automation in this context. And so design automation basically means you build these systems, and so you build graphs that have an engineering context. Yeah, this is like another tool that we used for this, for example. And so here you can see you try to connect different systems, and what you need to figure out is, are systems and components, are they compatible with each other? Do they work when you plug them into each other? That's the easy part, but then there's a lot of interfaces between them. There's a thermal interface, electric interface, data interface, then there's a communication bus, there is the software that needs to talk with each other, and so you need to figure out all these compatibilities. And so we try to encode that in a graph, but in order to find out all of these things in an automated way, so that's the hard part. Like once you know that, it's easy to build the graph, but first you need to do that. And so we went from completely manual more and more to automated, and it's I can already say it's not completely automated yet, because this is a really hard task, but we're in a good way. And yeah, another use case that you can do with this kind of stuff with graphs is, for example, once you figure out components and systems, and you are able to link them to the manufacturers, for example, you can do supply chain management with this graph that you build. For example, in the lower left, for example, you could only, for a product that you want to design, you could automatically select only components that have certain certifications. For example, if we talk about, so we worked on a surgery robot once, for example, and that's really important there, that you only use parts that have some sort of connection to, that you can put into a surgery room. The certifications are quite hard there. And or in the upper right is, like, let's say, I mean, in this current world, let's say you want to build something where no components from certain countries are in there, then if you have such a graph available, that's a pretty easy task. But the hard part is building the graph. And yeah. So what kinds of documents are we talking about to get that information from? There's this stuff. There's, for example, data sheets and certificates for products. Then there's web pages where things are offered. And so if you compare these, just for example, these documents that we have here with, let's say, legal documents, for example, or with a scientific paper or anything like that, these are completely haywire. They're just totally, yeah, the product sheets, they are totally wild. So we've actually done a lot of scraping with these product sheets, and you will never know what you come across with this kind of stuff. It's completely arbitrary, and yeah, and also it's not just the structure of the documents that is completely wild and has no standards at all, but it's also how the PDFs themselves are built. So it's mostly in PDFs. That's already one problem, because in PDFs there's no structured information at all. It only saves individual characters with its size and position, and then that's it. So even to extract a sentence, you already need to use an algorithm, figure out which characters are next to each other. Oh, that's probably a word. Oh, there's a little bit of a space. Okay, or maybe that's 2 words and a line. You know, so this kind of stuff you really need to build it up from the bottom. And so yeah, like HTML is much easier, or a Word document. But even then, you find these funny things that there is this one supplier who has only product sheets where there's no characters in them at all, but everything is a vector graphic. And so, and then you load the PDF, and it's 50 gigabytes for just a single, for just a little bit of text that's in there. Okay, so yeah, all these kind of things. And somehow somehow we had to cope with all of that. And so this is where this framework comes from in this environment. I think it makes a lot of sense. So I can't do the demo because it's not my computer here. So I will send around a Google Colab of that for later for people to try out. So it does work on Colab, and yeah. The only question now is if I let me try to open the. Jason, could I have your help for this? If we can open this thing in the browser really quick. At least I have the demo as an HTML file here now. Yes. Is this the right one? Let's check really quick. Yes. Yeah. So this is the right one. So this is just a Jupyter notebook, just as a little example and just as a teaser, sort of what you can do with it. So you basically you can load a document. So Pydoxtools is the name. So if you want to use it, you would where is it? Import Pydoxtools somewhere here. Somewhere around, yeah. There's a lot of import, yeah, and Pydoxtools visualization in there. So, but all you need is import Pydoxtools, and what you can then do, and that's also on the web page. Or let's start with the web page maybe first. That's easier. Can I open the GitHub page? No, I mean where's the browser here?
Oh, you want to go right in the browser?
Yes. Okay, and then, oops. Oops. Yeah, thanks. Okay, of course. I misspelled it. Ah, yeah, there. Oh, yeah, I'm used to German keyboard on my laptop. That's one of the differences. Okay, yeah, so there we go. So here the teaser is much easier. So basically you just do this. Is it recognizable? Is it too big or too small? Can you see it? Perfect, thanks. So yeah, so all you have to do is you do import Pydoxtools like this, and then you can load documents like this with the second line. And it accepts quite a lot of stuff already. So you can do PDF, Word documents, you can put in HTML files, URLs. It accepts things like JSON files. And then sort of automatically interpret it. And so the goal is to keep it for a start, keep it as easy as possible. So then you can extract things like tables simply by doing doc.tables. Okay, and then it will spit out all the tables it finds in a document. And you can answer questions on it and all these kind of things. So that's how, so you don't need a lot to use it and install it. It's in Python in the project. And in Python there's a store, PyPy, where you can download Python libraries, and it's in there, so it's pretty standard, the process. And okay, so let's go back to the other HTML file. Oh God, man.
How are you answering those questions? QA? What's the algorithm for the question?
You can either, so the standard is that it interfaces a Hugging Face model. So it's locally, so the standard stuff is locally on your computer, the inference. And yeah, you just load a document, and it's pretty good actually in what it answers. And in contrast to ChatGPT, the standard model that is configured in the library will not give you an answer if it doesn't think it's correct.
Can you repeat the questions if people ask them?
Oh yeah, so the question was how, when you do question answering on documents, how is that done inside the library? And yeah, so you can interface, for example, ChatGPT, and but the standard way is to do it locally on the computer for this.
Is that natural language query?
Yes, yeah, just a natural language query, yeah. And it will give you a single, so it's called extractive question answering. So when you do it locally, it will find a passage in the document that answers your question. So it will not come up or invent any question. But when you use ChatGPT, that could happen. So yeah, let's go back to the demo just a little bit to show the capabilities, what you can do. So for example, I think this is pretty cool. It's pretty hard to find this stuff in a good way. So this is document layout analysis. One of the things that works in the background. So it recognizes, this is a table, this is a PDF. It recognizes the images, the tables, and individual text, and it categorizes them and can make sense out of them. And that works for pretty much any document that you throw in there. For PDFs, this is really hard. This is why this shows a PDF. And especially the table extraction algorithms that are available nowadays, they're not very good. And this is also a constant work in progress in this library. But I think the quality is, yeah, it does pretty well, actually. And it also, this library, what it does well is it does that without AI. It's like not a normal thing today these days. But there's no neural networks or anything behind that, but normal algorithms. And it makes it very fast and very CPU efficient. So especially if you want to go large scale, and especially in the context of graph databases, what happens often is that you want to crunch a large number of documents. And if you can do the calculation within a millisecond or within 2 seconds on a CPU, that's quite a bit difference then for this kind of stuff. Could save you a couple days in calculation time. Yeah, so it spits out the tables, then just as an array for further processing. Another thing that it does, it organizes pages. So it tells you, and that's important when we talk about AI these days, so LLMs. When you just throw a PDF into an LLM, right now, what in almost any software, at least I don't know any example besides this. What happens is, for example, it will just do OCR on your PDF, which means is that, for example, a table that is in the PDF will come out as just text salad or something like that, okay? And or an LLM doesn't know where what is on which page, or an LLM doesn't know this is a table of contents or this kind of stuff. It can kind of figure this out, but you just lose a lot of information if you just simply do OCR on documents and throw it into an LLM. Then the LLM, yeah, I mean, like even a human couldn't do it. Like I wouldn't be able to make sense out of a character salad, which used to be a table once. So and so here it does this. For example, then you can replace tables like this. Okay, so so it just replaces everything that is a table in the document with a reference to the table which you can then extract. And so basically in the background, and I'll talk about this later, the framework sort of builds I call it a document graph. It's sort of a knowledge graph. It's kind of the same thing, but not really. And so I call it a document graph because I don't really have another word for it right now. So it's not just the things that are inside the document, so not just the relationships between words and sentences in this, but it's also enriched by the document hierarchy. So page 1 has table 0 and table 1, okay? And so that relation is actually important there because you need that. That's part of the document information, and you need that to make sense of the document. Yes?
Probably a parse tree or an abstract syntax tree that you're thinking of when you say document graph.
Sort of, yes, but this is a very hard work. So the versions that I publish, they usually work. I do unit testing on everything, and but what you said is so the question was what I'm using basically there. If I'm using a parse tree to do that, or like put the document in a tree, and yes, sort of, but this is probably the hardest problem right now in creating this framework, how to organize this. Because you have the graph on one side, and then you have, I'll show this a bit later, and the internal structure is that everything is built in pipelines. So in order to get there, you need to go through a lot of processing steps. And to map the processing steps, basically, on the graph is a really hard problem. And so I haven't quite figured this out. So the version that is online always works, and also the interface on top doesn't change as much. But internally, I'm learning a lot and building this, and it's being changed a lot. So I can't give you a definitive answer on this, in other words. Yeah, you can do easy things like keywords, text. So if we have a graph, it's easy to extract keywords from that graph. We can just do text rank and like basically the same stuff that Google does with the web. And yeah, get the most important sentences, keywords, the language of the word. So there's about, like, I don't know, right now there's about 150 different things that you can extract from each document. It's all the standard NLP tasks basically that are in there. And generate documentation. Yeah, that's not. And so this is one example for today. This is, for example, a little knowledge graph extracted from a Wikipedia article, I think, about rockets. So yeah, loading the Wikipedia article here, and then it tries to make sense out of it, and you can extract a knowledge graph. And so what's cool about it is that it's a one-liner. So you have you load the document here, up here. I don't know how I can mark it. I think I just need to press harder on your mouse, and it works. So you load it in one line, and then in another line, you extract the knowledge graph. And so you will get it as a, you can have several different forms. You can just get it as a table with the relationships, or this one here is a network X graph. That's a Python library that helps you working with graphs. And yeah, and then you can render it if you like to. So yeah, and there's just some examples, like, and a little zoom in to some of the parts of the document graph. So it kind of makes sense what it puts together, but I think the quality could be a lot better. So this is definitely one construction side right now. But then on the other hand, I haven't really seen any frameworks that like give you super high quality knowledge graphs from arbitrary documents. So this is definitely a work in progress. And I think also there's a lot of work going on right now in all kinds of communities because the LLMs really help here. They bring this, the large language models, they bring this knowledge graph creation really on another level. And yeah, so this is, yeah, so that was just a little, sort of the demo. And where is the, I want to open a, was it here? No, okay. Yes, back to the presentation. Oh, thanks. Okay, so that was the demo. So yeah, so we've mostly been through this now with the demo. So document can be anything, images, PDF, docx, odt, whatever. Okay, so this is kind of cool. Then, yeah, one thing I haven't mentioned. So we have, so this here on the right is, for example, one of the pipelines in the background. As you can see, they're quite complicated. So you can really build complex stuff. And this is now even one of the smaller ones. So, so I think the standard pipeline is like already like 2 or 3 times the size now. And this is probably the main feature of it. So the pipelines, they are lazy evaluated, so it really gets computationally efficient. And that is, again, important for graphs. Because if you want to extract information for a document to build graphs, you need to extract a lot of information at once. And what a lot of people are doing right now, for example, if you use, there are models out there, they're called document question answering models. And so you can, and they're very big. So on most computers, you will have trouble running them because they need so much memory and CPU and graphics card and everything. And so you can input mostly images and then ask a question for that. And the model will do OCR on the image and answer that question. But if you want to build a graph, you maybe need to answer, let's say, 1,000 questions, okay? And with that kind of method. And so for every run, you already, for answering every question, you need maybe 2 seconds or whatever. And so times 1,000, you can already see where I'm going. So this will not be very, so in real life, this will just not work in most cases. And so, but if you use these pipelines and they're lazy evaluated, you do, for example, the OCR only once. And then when you ask questions on it, or the graph mostly gets extracted directly because you extract semantic relationships and all of it. So this is, long story short, the use of pipelines here is actually pretty important. The other part is that when you do this not with pipelines, pipelines enforce a flat hierarchy. So basically in this pipeline, every function that is inside the framework can directly talk to another function. And that's also necessary because you, like when you do this with functions, basically the code just goes haywire. So I've tried, this is actually like the 3rd iteration of this framework or whatever. And so we did do it without pipelines at first and just plugged functions into each other. And that just becomes unmanageable very, very quickly. And so you need some formalized way on doing this. And every function in Pydoxtools, we call this operator. Every operator that is used in there is completely independent from anything. So it works on its own. It doesn't have any dependencies, and it only has input and output defined. And so if you do that, it makes it testable. It makes it bug-free, and like and so on, and all this kind of stuff. And that's why this flat hierarchy is important. So when you change one operator, doesn't mean that the entire rest of your framework just breaks down like a card house. But as soon as you go with functions and this kind of stuff and have side effects, that's exactly what's going to happen, and also happen to us quite often. Yes. So the the pipeline are important because a lot of these nodes that you see there and functions in the background, there's actually AI running. So you could also talk of Pydoxtools in some ways as an AI composition library. And it composes AI to mainly for extraction purposes. I mean, you can use it also for other stuff, but that's the main purpose. So we've already touched this a little bit now. I think the relations to why I'm here is already pretty clear. Yeah, so Pydoxtools has this document graph, and it mainly consists right now of the semantic relations between words in the document. The background, Pydoxtools mainly uses Spacey to do that. Then on top of that, it does co-reference resolution. There's a nice framework out there of fast co-ref, but you can plug anything in there. It's pretty easy, but this is the one that's configured by standard because it just works really nicely. And then we enrich that graph with the document objects from Pydoxtools, which is, for example, pages, tables, and just try to relate everything that's in the document in that graph. Or you can do address, you can classify text blocks. And so in the graph, we want to know what kind of text block is it. Is this an address? Is this a title? Is that like this kind of stuff? Yeah, I think the rest we pretty much have covered already with the demo. So I'm not going to go into too much detail there. Oh yeah, if any questions, then yeah. I mean, some people have already asked questions, but I want to make sure. Yes.
I had a question about unstructured PDFs. So you mentioned you take tables and you can turn that into like a CSV or structured data.
Yeah.
What about just general text? So like in a PDF might have different headings or sections. Is there an intelligence to how you chunk that unstructured data into structured data, or is it just like by page?
So there is, yes, and I'm working on that. It could be made better. Contributions are welcome. So I have right now what Pydoxtools is doing. It does what's the name of this again? I'm throwing away around so many words. Anomaly detection was what I was searching. So it's actually Pydoxtools uses an anomaly detection algorithm to search for titles and subtitles. And it basically does that so it creates a list of features for every text object it finds. For example, the font size, the where in the page it is, and these kind of things, and then basically everything, and then it tries to categorize it. So how it could be made better is to then learn these features and be like, okay, this is classify it really according to this is a title, this is a page number, or whatever, these kind of things, or this is a footer, this is a header, and but right now it just approximates it by saying the top. If the top 2% of strange features is probably a title, because titles are very rare in the document, and then the next 5% are subtitles, and then the rest is normal text, sort of like that. And tables were recognized in another way. So
so it's purely visual features. You're not taking like the semantic meaning. If there's like text that's the same font, but it says like section A, that wouldn't be recognized as anything, right?
No. Yes. Yeah. So right now, I think I mean, it's on the to-do list. It's mainly so one reason why I'm here is because I would love to have contributions to the project. So this is a good time right now to advertise for that. So we have like a to-do list of maybe 2,000 items or whatever, and yeah, it would be great to have people collaborating on this a little bit, because I think this is a cool tool, and to do this, for example, what you said, because I would love. So what I have on the to-do list is to have a classifier sitting there and explicitly telling you from the position on the page, from the font size and whatever, this is a title, this is a page number and whatever. And then you wouldn't, I don't want to do it with I mean, so ChatGPT can do that. But ChatGPT is like, so in German, there's a saying that I know, it's with shooting with cannons on sparrows. And so, yeah, sort of like that. Yes.
To answer this structured data from unstructured data, could you create a list of questions that you would ask of a collection of documents, like that would become the columns, and like you have a bunch of data sheets or requirements, specification spec sheets for a bunch of pieces of hardware.
Mm-hmm.
And so you can make each one of those spec sheets a row and a table, and then you can have a bunch of questions that ask, like you had in your example, what is the RAM, what is the voltage, and so on. And
yes.
you can just ask all those questions in one of your pipelines,
Mm-hmm.
and then construct that structured tabular data from a collection of documents. Is that correct?
Yes, yeah, that would probably be possible. Although I would probably approach this different now. I would probably go through a graph doing this, and directly, because the graphs are actually good enough to extract. So, I mean, this is the kind of the stuff what we created the framework for. And so we're doing this all like statistically, which is a lot more efficient in this case. For example, specs are mostly in tables. And tables are already pretty structured. So it's actually a pretty nice way to extract the features is there by just like going through the tables and relating that to the documents.
I'm just thinking of like say you're processing a bunch of books or a bunch of unstructured data. So it's not a spec sheet. It doesn't have tables in it.
Yeah.
It's purely unstructured data.
In that case, you could totally do that. Yes. I have actually, there's a class in there already. Let's see. What time do we have? How much time do I have?
5:12. So
I should. So obviously I could talk about this for hours and hours.
Like a great use case would be if you're doing some medical research and you have 1,000 papers on a particular drug, and you want to know about all the side effects. You say, what are the side effects of this drug? And you ask that of 1,000 documents, and now you've got structured data about all the statistics about that drug.
Exactly, and I actually there's already this here. So how do we combine multiple documents? I have there's actually a class in Pydoxtools already. So there, Pydoxtools, so first of all, there's a pipeline class, and then there's the document class on top of the pipeline class, which sort of creates a like an opinionated standard pipeline, which can handle documents, okay? And then there's another class, which is in there already, which is this document bag class. And it basically is a way of handling a bunch of documents, or a bag of documents in this case. So it's a document list. The reason why it's not called list is because a bag means it's a list, but the order is not guaranteed. So and the reason why that's the case is because it works on backend that's called Dask, and which basically means you can run this on a computer cluster already, and so this document bag would work really well for this, because through the document bag you have direct access to all the functions that you have in the document class. So you would just throw in, for example, a directory with those files and ask them like the question, then it would automatically ask the question to all the documents, and also on different computers, because if you have 1,000 documents, you will probably need that to do that with several computers. And this document bag is exactly for that task. And then from document bag, you can get out CSVs, or it already has connectors for example, an SQL database, so that you can just directly feed it into a database from the other side. These are all, in comparison to the document class, this is not super mature yet, these features, but they work. So they're unit tested, yeah. And that's pretty much it. Oh yeah, so yeah, one more question before we go to the next one. Yeah, I can just put that, so yeah, if you guys want to, that's the link.
If you went to look for the Python notebook, I didn't see it on your GitHub. Is it on GitHub, or is it in your collab?
I will send around. So I have I thought I would have the demo here, so I'm gonna build the code up. I started doing this earlier.
Okay,
like
cool. All right, I'll come
10
find you
minutes
later.
before the before the talk. Hadn't gotten it ready yet, so
If you registered through Eventbrite, we'll send an email afterwards.
yeah.
With all the links.
I will send it around, but I will also put it on the GitHub.
Perfect, thank you.
Yeah. With the demos.
Right, cool.
Thank you, Thomas. Actually, let's not just rip it out. Okay. All right. So our next speaker is Vish. Just a quick intro. So Vish was part of a team at the SDxAI Hackathon, and his team placed third with a LLM on top of a knowledge graph project. And I got so Vish wasn't aware Neo4j had existed previously, so he went and created basically his own version, which he'll talk about.
Yeah, so I'll be talking about my lessons from building a custom graph query library. So like this was in the beginning of my programming journey when I made a lot of mistakes and I learned why basic programming best practices are the way they are. So I'll be sharing some of my insights with you guys today. So around 2 years ago, I think 3 years ago, I took up a project, to build a history bot for UCSD students. So like we had this world history course, which is really famous across UCSD for being super hard. You need to memorize so much and you need to keep track of all this stuff. So I thought, a bot or an AI that could, really save your, slash your study time by like 30% would be something that would be really cool. So I came up with the concept called Cleverly. So what it does is you could upload your history textbooks and it would generate a detailed summary. It would generate flashcards. It would create mind maps for you. And then it would also create a question answering tool where you could ask it any questions and it would provide an answer with a citation. So this was before all the LLMs like ChatGPT. So back then it was really cool. And so regarding the mind map feature, what I did was I just had this system which would extract triples like subject, verb, object triples, and then it would use graph-based library to construct a graph, and then it would give it to the student. And basically it was pretty simple and students seem to like it, but I thought, if you're only extracting subject, verb, and the object, you're missing out on so many, so much of information that exists, in the prepositional phrase or in so many other phrases. So I was thinking of, creating an advanced version of the mind map feature. So that was when this whole process began. So I was looking for a really good graph traversal library. So on the left side of the slide, you can see all the search prompts I had on Google. And on the right side were the libraries I came up with. Like only the 3 libraries like NetworkX, iGraph, and PyGraph. I didn't come across Neo4j because for some reason, none of those prompts gave me Neo4j in the first page of Google, and unless Jason told me.
Because Python was in your query.
Yeah. I mean, Neo4j does have a Python, right?
I'll talk to our ad people.
SEO needs to work.
Yeah. So I looked into NetworkX, iGraph, and PyGraph, and they didn't, exactly fit the kind of, thing I was looking for. Also, they had a really high learning curve, so I thought, let me just try and build something of my own. It would be really, fine-tuned for the purpose I'm using, and that's how I started the task. So the fundamental requirements were simple. Get it up and running quickly. I don't want to run any servers. I don't want to protect any servers. I just want to get it up and running quickly. I need accurate pattern matching because that was at the core of the mind map feature I was working on, like I'll be discussing in the later slides. And good developer experience. Like I said, I chose against using these libraries because of the high learning rate. So good DX was crucial for me, and the result of that brainstorm was a tentative implementation design that, like I have mentioned on the right side of the slide. So I would use Python classes like templates as nodes. So basically, I had 10 to 12 template classes like empire, emperor, wars. They're all historical terms, and those were like templates that I would clone each time I needed to say to construct a node. So those would act as the nodes, and the variables within those classes would act as the node attributes, and the variables would refer to each other, which would be a proxy for the edges. And when it comes to the pattern matching, I thought regular expressions were pretty good at that, so I could use that. Like I was considering nested for loops, but that would be terrible for the runtime. So I thought of using regular expressions. So I'll give you an example of how the whole thing worked. So like I said, there were like 10 to 12 node template classes. And I'm considering, say, two of them, Empire and Emperor. So, so you can see the Empire class there. It would have an ID, a founding emperor, time period, capital city. So every time you had an empire, it would clone that class and fill in the attributes for that. So so I'll put it this way. So when the student uploads, when the students upload their textbook, the AI runs named entity recognition on the entire text. And let's say one of the named entities is an empire based on the classifier's output. The empire class would be cloned, and it would be given an ID, and let's say the text contains something like Roman Empire, right? So the named entity recognition would return that as an empire class. So this particular class would be cloned, and it would be assigned to the Roman Empire string. And let's say the text also mentions that the founder of Roman Empire was Augustus Caesar. So an emperor class would be cloned, and then that would be assigned to the word Augustus Caesar. And because Augustus Caesar founded the Roman Empire, under the node Roman Empire, the founding emperor would refer to the node that contains Augustus Caesar. So that's how the entire structure worked. And I also had a string form, like you can see below. So the string form was basically for the regular expressions to work. So the format for the string form was node class slash then there will be the ID, then the attributes in nested parentheses. So let's say Augustus Caesar is the founder of Roman Empire. So the founder so this nested parentheses, can you see my cursor? So this nested parentheses would contain the whole structure for the node that contains the word Augustus Caesar. So that's how you got the entire string. And I would keep track of all the head words in the graph so that I could create the entire string form and use the regular expression pattern matcher. So coming to the pattern matching examples, I would just instead of
if you squint at that regex pattern on the previous slide, it kind of looks like cipher.
Which
you
one?
basically wrote a path. Right?
Yes. I got this pattern from what's it called, dependency parsing string format. So they had something similar. So I thought that would work for this case as well. So I was inspired by that. But you're right. It's very similar to cipher. Yeah. Yeah. So coming to the pattern matching, I was against the idea of using nested for loops. So I would just come up with one pattern that could return whatever I wanted. It was a little complicated, but I thought once I get the hang of it, it would get easier and easier. So here I've given two examples of how the pattern matching would work. to find all instances of var containing a participant with an ID I. So using the string form that I got from here, I would run this regular expression pattern matcher on top of that, and then it would return all those IDs to me. And similarly, to find all instances of the node alliance of a participating empire with a time period with a time period with an ID I. So if you run this regular expression pattern matcher, you would get all instances of what you're looking for. So I used this pattern matching function basically for graph completion. So I'll put it this way. So the student uploads their textbook, and the named entity recognizes all the entities. It constructs the graph, and then then the last step is to complete the graph. In other words, like for example, if you say if the text says Alexander the Great succeeded Philip II as the king of Greece, right? And then it says that all the kings who exist, all the Greek kings who existed before Alexander the Great are known as Hellenic kings. So, by any rational person would conclude that Philip II was therefore a Hellenic king, right? So we want the graph to do the same inference. So what I would do is that using this regular expression pattern matcher, I would find all the all the Greek kings who existed before Alexander the Great, and then I would complete that graph. Yes.
This is probably stupid, but what I see function names and variable names inside of what you're calling a regular expression pattern.
Yes.
Is that a new kind of regular expression? That's not the kind of I'm used to.
Yes, I forgot to mention that. So I downloaded the regular expression library, and I added a custom function where, because just so that I could run this.
So you have functions and variables inside of your regular expressions, and you have some sort of way of parsing that and turning it into a regular expression.
Yes. So I added a function to the regular expression library where you could add functions. So you're referring to the function contains, right? Yeah.
How did you
contains returns true, then the pattern matches, or else it doesn't.
So you like imported RE, and then you said RE dot, and you added your own parser.
I downloaded the RE package, and then I went to the source code, and I changed the way it parses it.
Holy cow. Okay, I get it.
How did you index this? Like when you actually query your data store, like does it return in any type of reasonable amount of time? Like
query the data store in the sense. So the student upload their textbooks, and it parses right on top of that, of the content present in the textbook.
How long does it take to parse a typical textbook?
Depends on the size, but for UCSD, readings, they're typically like 15, 20 pages. So that is within 10, 15 seconds.
Nice.
Yeah. The entire document is like thousands of pages, and that would take much longer.
It's about a second per page.
Sorry?
About a second per page.
Yeah. Depending, yeah. So I customized it to the kind of textbooks kind of readings that UCSD gives its students, and I tested it on that. So yeah. So after the graph completion part of it, then GraphViz comes into the picture. It creates the graph, the knowledge graph, and it fills all. It makes it fully colorful, and then it presents it to the student. So the problems I ran into with this graph library is that every new node, like I said, I had node templates for each of those categories, and every new node I added would require changes throughout the code because I hadn't modularized the whole project. So I learned the hard way the importance of modularizing code, the importance of keeping things separate and independent. That was one huge problem I ran into. Second thing is that regular expressions were harder than I thought. I thought, once you get used to them, you'll understand them. But generating them and reading them all the time became a little bit of a problem. And then continual maintenance and optimization was a big problem. Like I understood firsthand the amount of effort it takes to build and maintain a library. I began to appreciate the kind of effort it takes to maintain an open source library and so on, because as a one-person team, I had to work on several features. I couldn't keep coming back to this particular module of the project and only work on that. So these are some of the big problems I ran into. But on top of that, I also discovered that whatever I was looking for was already out there. And like when I met Jason, he told me about the Cypher query language, and I realized that whatever I was trying to do was already there. And apart from that, I also realized that NetworkX has something called as the VF2 algorithm. So it was it was not a friendly name. You cannot make the connection between something called VF2 and subgraph pattern matching. But if you look under the VF2 category, you will find functions that do exactly what I was looking for. So it took me a while to learn about learn that this already existed, but but I did. So was it all worth it in the end? So obviously I rewrote functions that already existed. I could have devoted that valuable time to other features that customers were asking, right? I could have devoted that valuable time to reducing the latency and increasing bolstering the security. So yeah, and obviously, like I said, my whole project was structured as one monolith. It was not modularized, right? So like if you mess up with any small part of the code, the whole thing would stop working. So reintegration was a big problem. Like when I had to migrate from my library to something like Neo4j or NetworkX, it was a huge problem. Whereas coming to the pros, I learned, like I said, I learned firsthand why programming best practices are the way they are, right? Like people like me have run into similar problems before, and that's what led them to, codify these rules, and they exist for a reason, and that's what I learned. Apart from that, I got to learn. I got to learn how graph traversal works in depth, how regular expressions work in depth. So that was a huge pro, I would say, and obviously appreciation for open source libraries like NetworkX, Neo4j, and Spacey. That was also a huge learning lesson for me. And my key takeaways: first thing, search for existing solutions as much as possible. It doesn't matter if you take weeks. It's better than spending a month writing your own and then realizing that something like that already exists, right? So I would now use ChatGPT to the maximum, Google to the maximum. I would read Medium blog posts, even if the Medium blog post does not discuss something that I'm working on currently. I would just read it generally and keep it at the back of my mind if I ever come across something similar. I would just recall whatever I've read and so on. And lastly, I would try to network as much as possible, meet more people like Jason who would introduce valuable libraries to me. So that's first thing. Second thing, I learned to keep my project modules independent so that if I have to switch, it doesn't, the whole system doesn't burst up in flames. And lastly, support open source. Like I knew that cloud service providers like AWS and GCP have their own graph traversal programs, but the thing is, I feared getting locked in to their system. Like I don't want. I really want to know what algorithms are running on my code, what algorithms are running on my data, but the thing is, their algorithms are proprietary, and it doesn't give me, as a developer, I would like to have full control over what's being run on my data and so on. So I realized that, in order to strengthen the developer community and to make sure that like let's say if most of the community uses a proprietary architecture, you have no choice but to use it as well. So open source helps developers stay away from that. So I made a personal commitment to support open source and raise awareness about it in events like these. So that was another huge takeaway for me. Thank you so much. This is the website where I have my project. You guys can check it out.
I just want to give you a chance to brag a little bit. What was your peak monthly subscriber count?
For
paying subscriber.
Paying subscribers.
Yeah.
The number was around 100 to 120 at the peak, and this was before.
You were a sophomore in college, right?
Yes, and this was before the era of ChatGPT. Now students would rather use GPT-4 and so on, but.
And this is for a history course. It's a bot to help people with their history course.
Yeah. Yes.
Oh, yeah.
Yeah.
Yeah. Did you put this into a knowledge base of any kind, so that, for example, if somebody gives you a history book of version 3, and 3 months later version 4 comes out, and let's say 90% of it is the same, you don't have to upload. You don't have to upload and reinterpret all that new text.
Yes, that was something that was in the works. It was one of the features I had planned, but yeah, something like that was in the plans.
I understand the difference between a plan and execution. So.
Yeah, like I didn't get to completely execute that the feature you just mentioned, but yes, that was a really good idea, and we were working on it. Yeah.
So, yeah, my question is related to Gordon's. Is the graphs generated by your software, or those persisted in storage somewhere? So, or does it always generates them at runtime where you upload the book and so on?
It was always generated when the student, and when the student uploaded their textbooks. But the students could view the graphs they had generated in the past, but other students could not view, the graphs that someone else had generated. Yeah.
Out of curiosity, how many regex templates did you need for like full coverage?
Oh, so the regex templates were just for the graph completion aspect, right? So I had, somewhere between 10 to 15.
Oh, okay.
Yeah. I mean, you could add more if you want to improve the experience, but yeah.
At first, I just want to give you the props that you started this and reinvented the wheel, because I think it's actually pretty cool. My experience is that on the surface, most libraries look like they can do every job for you, which is not the case. And when you look under the hood, you actually see that most libraries are actually quite simple underneath, and that it doesn't take that much effort to implement them. Just the surface is really, the people just knew what they were doing there. Okay, and so having said that, so for example, with Pydoxtools, we did the other way around. So we knew all the libraries, or thought we knew all the libraries, and so we started extracting, and then we figured, okay, on the top surface, it can't do what we want. So, but we lost a lot of time trying out all these libraries, and then just did it ourselves with our own code, which was way less effort and faster. Then we figured, okay, we want to extract tables. Also tried all of the different table extraction methods out there. Didn't work, wasn't good enough, so we had to do it our own again. Then we started, then we realized that the PDF extraction software was also, like, there were flaws
everywhere there. So we did our own PDF extraction, like PDF parsing library on top of that. So we had the completely the other way around the experience. Okay, so it's not necessarily a bad thing to also try to do the stuff your own and also implement it your own. You will always have something that no one else has done this way yet before. For example, what I've seen there, you were quite creative, and I totally think that this could end up. So I think that's needed. Like if no one did that, then no new libraries would be written anymore. Sort of basically like that.
Yeah.
And so having said that, now that you know the other libraries, do you think there is one part that other libraries could use from what you did?
Yes. I would. Okay, so I mentioned the VF2 algorithm here. So, like I tested the speed of VF2 algorithm and then the speed of the regular expression pattern matchers. And surprisingly, they were almost the same. Whereas, you know, it was supposed, like VF2 algorithm is based on a paper that was released, I think in 2018. So, you know, it should be better than a pattern search algorithm that has been here for decades, right? So that really surprised me. So if not better, I would say something that is comparable with state of the art, right? So that's one thing I would like to mention. Yeah. Like I did speed tests with a lot of articles and stuff. Yeah.
What was your GUI?
For the website?
Yeah. I mean, was it primarily just text boxes or what?
For the website, it was just React on the front end and JavaScript on the back end, and I used Fast API, you know, on AWS, and it would call the API. It would just pass the it would, like when the students upload the textbook, it would just pass the information to the API, and then API would return all the information, and it would be displayed on the front end.
Did they do this via an email, or was it a website that you developed, or?
Yeah, it would be displayed on the website.
So do you have that website?
Oh yeah.
Cleverly.io, but it's.
Yeah.
Is it still up and you can still use it, right?
It's still not. It's not up anymore, but the legacy software is still there, and you can probably try out the demo, and you can try you can watch how the process works. Yeah.
There's videos of the,
Yeah,
of,
the videos.
of the process.
Yeah. Thank you. Thanks so much.
Thank you, Vish. All right, one more round of applause. That was cool. Okay, so we're just about out of time, so I'm gonna let's see. We'll do the 2x version of my talk here. Okay, real quick. So I'm going to talk about a graph data generator package that is available on the PyPy org, basically the Python repository index. And real quick, the use case for this is if you're building an app and you need real data, but you don't have the data because your app is brand new, right? So you want data, but you don't want just like a simple piece of it, right? You don't want a single table of people, single table of companies, et cetera. You want something that's resembling real data, right? Which is going to be complex, interconnected tables. So existing solutions are really great at giving you those single tables. So you could create a bunch of single tables and kind of test off of that, but you're not going to get a real experience, right? Because that data is not interconnected. So fast forward, I've been working on a project, calling it the graph data generator. So this package takes a JSON configuration that represents your data model, and then basically creates a mock data set of interconnected tabular data and puts it into a zip file. Inside that zip file is a bunch of CSVs. So you could upload those CSVs into any database that you can upload CSVs to. Also included is basically lookup tables, right? So you've got people, some relationship to, say, a company. They work at a company, used to work at a company, etc. So all those intermediary tables are also available in the CSV. Also included is a JSON file that is a little complex, but it basically maps all those CSVs together. And that can be used by a Neo4j tool called Data Importer, which allows you to basically dump a bunch of CSVs, link them all up, and then you could import it into a Neo4j graph database instance. This package is ready to upload right out the gate once it's ready. Okay, and it also includes a log, so you could see if something broke, you could check that out. Okay, so the input JSON file. So this is a little complicated to look at if you're to do this in a text editor, but basically it's a JSON dictionary with two main keys, nodes and relationships. And each one of those keys is a list of dictionaries representing those nodes and relationships. So here we've got the important bit, which is the ID, caption, or the label of the node, and then a bunch of properties you want to associate with it. Once you've got two or more of these, you can put in a relationship that just ties one node to the other node. You can define what that relationship is called, add properties, et cetera, et cetera. So you can build out an entire graph in a JSON file. Okay, so that's not ideal to work at all in. So fortunately, someone else at Neo4j has built this great free tool, and it's available online. It's called arrows.app. And basically, you can just assemble your data model in it, right? So if I show this real quick, you could. So this is an example. I'll just make a new one real quick. So put this over here. So if we want to do something that's just represented today's meetup, right? This person is at a meetup, and this meetup is part of an org. Oh no, let's say in the city. So person attended. So you can see where you can go with this, right? And you can add in, extra properties real quick. Name. It's gonna be some sort of string. Person, also, some sort of string, etc., right? So once you're done with this, you just click on the download export button. Wow, great. We've got that whole JSON file already ready to go. So this can be copied and just inserted into the package as an input.
Wait, I'm sorry, Jason, I looked away. That was in Arrows, you just clicked, what button did you click in Arrows?
Yes. So up here in the upper right, download export. So here, Arrows
That's
is
the same JSON that you use in your data generator?
Yes.
Oh, cool.
So I use this spec to run off of.
Oh, cool.
Can you use the data generator input file to import it into Arrows if you build it by hand?
Yes. Okay. So you're asking if the
Import the data generator input.json and graphically display it in Arrows.
No, not for Arrows. So the JSON is only an input for the script, right? So the script doesn't pump out a JSON file that's compatible with Arrows, right? So when I mentioned earlier that it includes a JSON file, that JSON file has a different format. It's meant for data importer. So data importer uses a different format than Arrows. Them being the same would be great, but that's not the case. But you can take a JSON file, and I think even if you stuck it here, you can definitely import it, and it'll visualize that JSON file, right? So if you did it by hand and it didn't have any sort of syntax errors, you could dump it right into Arrows. Yes.
So this is like a schema for a graph, and then this data generator then walks through a table and produces entries and an actual graph. Is that what it does?
Yes. So generally, so it'll go through that JSON file, right? It'll look at all the nodes. It will generate X number of nodes and all its properties by running basically a bunch of other mock data packages, generating first name, emails, blah 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 blah, and then it looks at the relationships, and then it creates the relationships that tie the different nodes together. That's the simplest explanation.
So it's used for creating fake data. Is there any use for it on real data?
No, this is purely for creating mock data. So the better name would be mock graph data generator, but it was such a long name, I just made it graph data generator. Right. But yeah, you're right. So this is only for creating basically synthetic data, right? Data that is not real, doesn't help you produce any real data. Okay, so this is arrows. That's how that works. And then, what was I saying? So you copy and paste the JSON and give it to the script. It'll pump out. So we could actually demo this real quick. So this is an older version. Okay, so I built the Streamlit app around the script. Well, I kind of built it all together originally. But anyways, now the newest version of the Streamlit app calls the script, or calls the package to produce everything and get it kind of all ready super quick. So if you go here, design, you can see we have the Arrows app is embedded inside the Streamlit app. And I just put in sort of this convenience list on the right to allow someone to copy and paste the configuration code for defining the different properties, right? So if we want to do like somebody's first name, right? Or we just want a bunch of mock fake names, we're going to copy and paste this stringified JSON object. That's all they are, right? It just defines what generator I should use and pass any args into it. In this case, I don't care what kind of first name, so it has no args. And we'll just do this with city as well. Okay, so that's enough for an example here. Okay, so what I'm going to do is I'm going to copy this out, and this is just my insertion for the code. You can see I have a downloaded zip ready to go. And if I open that up for you, see here, tiny, that I've got a bunch of CSVs that show like the city meetup person, those were the nodes, and the lookup tables are the meetup in a city person attended.
What the size of the workload?
What's this?
What is the size? How many, gigabyte or something?
Oh, what's like the max size? I don't know what the max size is yet. I would probably keep it to under 1 million nodes. But oh, okay. So one thing I kind of skipped over is if you do not define like how many of each node you want, it's predetermined to just randomly create between like 1 and 100, I think. But if you wanted a specific number, there are a couple keywords in the system, right? So one is count. So I want 10 people, and we'll just do 1 meetup. And well, we're only gonna have 1 city. We can make it more interesting. State 3. And everybody attends only, I don't know, between 0 and 3 meetups. Okay. All right, so we put this, throw it in here, generate a new zip, data 1. So we can see if we open this up, we should have 10 people in here. And 1, 2, 3, 4, yeah, 10. Okay, so once all this data, so this pretty much all the script does. So you can use the CSV data wherever you want, and that sort of interconnectedness exists. You could, if you're using Neo4j, you can actually import that data. So this is the data importer tool, which is part of the main dashboard UI, but you can access this directly to access a Neo4j instance. So here, just by clicking the triple dots, open model with data, it will open that zip file and basically blow it up, right? So it'll put all your CSVs on the left. This should visually match up with what you designed in Arrows. And then if you click on things, you can see the properties were added. Under the hood, I add a UID just to help it distinguish things. And then you would just run import, which to connect to a database. Give it a few seconds to import. Hopefully everything's green, and then immediately you could jump into a Neo4j database and enter a password again. And then I'll simplify this. Oop. So here I'm just telling the Cypher, just give me everything. So this is the data that was produced and ingested, right? So we've got the 2 meetups, or the 2 cities, 3 meetups, and there should be 10 people here. And you can see here, because I randomized how many meetups they attended. Sorry, I'm talking really fast. Here, right? Oh no, I didn't add the count. Okay, so it just randomly chose.
You did on the other one. There was one that you did.
Right, here. So here it was randomly creating relationships, right? So if it's a 0, obviously it's not going to create a relationship. 1, great. 2, then I'm going to connect you to two other data stores. Yeah, so like this person attended 2 meetups. So you can see basically you can design any sort of data model you want, add in a bunch of numbers, choose a couple mock generators, and boom, you've got, either a very small data set or a reasonably large one.
I guess I missed on the mock generators. Like you can do like regex pattern matching, like employee IDs look like this, or like we expect a driver's license number to look like this.
Like a pattern?
Yeah. You've got those, or you can plug those in?
Not yet. So I was trying desperately last night to add in a feature to allow you to combine multiple generators so you could create patterns, right? Like, so I want all licenses to start with XYZ and then either randomize or hash. So to take all these different generators and mix and match them. It's kind of working, but not working fully yet. So I didn't want to demo it. But hopefully by the weekend, that ability will be in.
So the names, you just have some sort of a table of names that you just randomly choose from?
Yeah, so there's a couple different name options, right? There's Faker library has like first name, last name. And so I'm using Faker for a number of the generators, but not all of them.
Got it.
So if you wanted to draw from a list, I added a string from CSV. Here it is. So here you could put a URL path to any CSV file, and it will use one column as a source to choose data from. Right now it's random, but it's easy enough to create a sequential, reader. Okay, yes.
Can you add timestamp like as time series sequence of
yes.
events?
So there is a date time option here. So I've only got one. So here you could specify, it'll randomly choose a date unless you bracket it to oldest, newest date exactly the same, but you can give it a range. So that's moderately useful, but it'll be better once I'm able to combine several different generators and then do something more interesting. So. Yes?
Do you have a template guide or anything like that where you can just click on something and bring something in? For example, if you wanted to start out with who, what, where, when, why, and how, you click that, it puts all those nodes in, and then you start filling them out?
No, that's a great idea. One thing about Arrows, which is convenient, is it can connect to a Google Drive instance or even store locally. So you could pre-build your own templates and then draw from that. But that's a good idea, yeah. And that would talk to Chad's suggestion of being able to take the JSON spec and load it into Arrows. Although right now this is really set up to take the data and load it into data importer. But yeah, it shouldn't be very difficult to go the other way around. Cool. All right, did I make it? All right, 1 minute left till 6. Awesome. We have time for one 30-second question.
You want to standardize this like TPC? You got a standard, scale factor or.
At this point, I'm just happy to make it work. And there are two main features I want to add to this. One is getting the combination of generators to work. and then parameterization, right? So that you can have some sort of outside weight, control how you want to distribute the data. So you could create all sorts of more interesting data sets once you're able to do that. So that's the only thing on my roadmap at the moment. This is public, so anyone is able to commit. Yes?
Does it map relative, can you map relative to the number of connections? So let's say if you got three nodes that have only 2 or 3 connections, they go in the center, and the ones with a whole bunch of connections, or maybe only one connections, are going out to the outside.
Not yet. That would come with parameterization. Then you would be able to do that. Cool. All right. So I'll send links to all these tools and whatnot also in the email. If you did not sign up through Eventbrite, come see me afterwards so I can get your email to send you, or go back to Eventbrite, sign up, and then that will give me the email to send you info to. Okay. If there's nothing else, then thank you everyone for coming. Thank you, Chad, for setting this up at Intuit. Really appreciate it. Thank you. Yeah.